today I'll solve one fluid mechanics problem and I will show you how to use Bernoulli's equation and solve this problem. So now here problem is water flows through the combination of pipes and nozzle as shown in figure 6.2. Find the diameter of pipe at section 1, not section 1. Section 1 diameter is already given, so that will be section 2. And then suitable data at section 1 and section 2 are given, neglecting frictional losses. Now here that this is the pipe, okay, pipe, and this is nozzle. This is nozzle. Now the datas are given, that section 1 the datas are given, section 2, section datas means here section 1, section 1, so datas are given, so P1 is given, so that is 5 bar, and then Q is given, so that is 220 liters per second, and then D1 is given, so that is 50 centimeters. Now in that section 2 only P2 is given. P2 is 1.05 bar, that is given. Now Q is not given, Q2 is not given, and D2 that is not given. Now from the datum line, this is the datum line, from the datum line to that pipe center line, so that distance is given, so that Z1 is given, so that is 12 meter, and Z2 from the datum line to nozzle center diameter, that is given, so that is Z2 is 5 meter. Now we have to find out what will be the D2. So finding D2, so first here we can use Bernoulli's equation. So now what is Bernoulli's equation? So Bernoulli's equation is nothing but P1 by rho V1 square by 2. So what is Bernoulli's equation? Bernoulli's equation. So that is P1 by rho plus V1 square by 2 plus G Z1 is equal to P2, final equation at section 1 and 2, P2 by rho plus V2 square by 2 plus G Z2. So this is the Bernoulli's equation. So okay, so again Bernoulli's equation I can write again. So okay, so that is the Bernoulli equation. I can select that. Copy and then I can paste it here. So this is the Bernoulli equation, we wrote that. Now here, so P1, if you see here, so P1 is known, and then V1 square is not known, then Z1 is known. So now we can see, so here this is known, this is known, this is known, this is known. Now this is V2 square is not known, V1 square by 2 is also not known, means V1 is also not known, but that Q1 is also already given here. Now that Q1 is equal to 220 liter per second, so that is given. So now from here we can easily calculate, means we know, so first we have to convert to liters to meter cube. So now we can divide it with 1000. So 220 by 1000. So that will be meter cube per second. Now according to continuity equation, we can write that Q1 is nothing but A1 V1. So now here Q1 is known, so A1 is also known because D1 is given, so that is 50 centimeter. So now we can convert that to meter, so 50 by 100, so that is meter, so that is 0.5 meter. Now from here we can easily calculate V1. So V1 will be Q1 by A1. So now Q1 is already given, 220 divided by 1000 divided by A1. A1 is pi by 4 D1 square, that is okay, so we can do that. So that will be 220 divided by 1000 divided by pi by 4, D1 is 0.5 square. Now if we do the calculation, I think we will get V1 is 1.121 meter per second. Now V1 we got, means V1 is equal to 1.121 meter per second. So that we know from this calculation, so that is known. So if we know that V1, so now here this is now become known from here. Now we can use Bernoulli's equation, we can easily calculate V2 square by 2. Now how do we calculate that? So we can put all this value. So again we can put all this value. Now P1 is given, so P1 that is given, P1 is actually that is given, so that is how much? So I think that is 5 bar. 5 bar is given, is 5 bar. Now from 5 bar we can easily calculate Newton per meter square. So 5, you can write 5 into 10 to the power 5 Newton per meter square. You can write that. Now means 1 bar is equal to roughly 1 into 10 to the power 5 Newton per meter square. So from that we can easily calculate that P1. Now what will be the P2? P2 will be P2. Okay, so that is okay. So now P2 is given. P2 is how much? 1.05 bar. So that is 1.05 into 10 to the power 5 Newton per meter square. Now V1 we know, so that is 1.121 meter per second, and Z1 we also know, Z1 is 12 meter, and then okay Z2, okay V2 is unknown, so that we have to find out. Okay, find out, and Z2 is given, that is 5 meter. Now we plug all this value. Okay, so that will be 1.10 to the power 5, sorry, 1 P1 value 1 into 10 to the power 5 by rho is water, so water density is 1000. Then V1 square, V1 is 1.121, okay, v1 is 1.121. okay, so that we can 121 square by 2, and then gz1, g is 9.8, 9.8, 1 into z1 is already given, that is 12 meter, that is equal to so this is not 1, this is 5, right, v1, and this is p2 is 1.05 into 10 to the power 5 by 1000. Then v2 we have to calculate, so v2 square by 2 we have to calculate, and then gz2 9.81 into, I think z2 is given, so that is 5, right, 5. Now from that, so v2 square will be, if you do the calculation, I think v2 square will be something, what, how much? Okay, if we do the calculation, v2 square will be something 928. Now v2 will be root over of this, so that will be how much, something 30.47 meter per second, so that is v2. So now in this case, so we get that v1, and then we also get that, okay, copy. So now we know, in this case, so v1 we know, v1 we know, that is 1.121 meter per second. Okay, and here also v2 we know, v2 is 30.47. Now we have to calculate d2. Now according to continuity equation, we know that q1 is equal to q2, that is q, that is 220 divided by 1000 meter cube per second. So now, and also know q1 is that volumetric flow rate is nothing but that q2 is equal to q is equal to nothing but a to b2. Now from here, so that is 220 divided by 1000 meter cube per second. Now from here v2 will be 220, not v2, so we are calculating v2 is given, so we are from here we can calculate a2, so a2 will be 220 divided by 1000 divided by v2. So now v2 is given, 220 divided by 1000 divided by v2 is 30.47. now if we calculate, so a2 will be, a2 is also okay, so we can also do, okay, a2 is equal to 7.22 into 10 to the power minus 3 meter square, and we also know a2 is nothing but pi by 4 d2 square, that is 7.22 into 10 to the power minus 3. Now from here we can easily calculate d2. So now here, from here d2 square will be what, 4 into 7.22 into 10 to the power minus 3 divided by pi. Pi means 3.14. So that will be, if you do the calculation, that will be 9.1977 into 10 to the power minus 3 meter square. Now from here d2 will be 0.0959. So that is roughly 9.59 centimeter. So now, d2 will be, okay, d2 will be 9.59 centimeter. So that is the answer. Thank you.